From the dawn of time, when our planet's atmosphere was overwhelmed with carbon dioxide, microorganisms flourished in all of the oceans of the world. For billions of years, among these organisms, the unicellular plants, microalgae, trapped the carbon atom from CO2 and converted it into oil, leaving behind as a legacy an oxygen-rich environment and vast deposits of fossil fuels. Since the Industrial Revolution, mankind has reversed the process. Burning fossil fuels has liberated the trapped CO2 and produced acid rain, acidified our oceans, and reduced food supplies. Our actions are creating climate change. In our insatiable quest for progress, we have depleted the stored resources built up throughout billions of years, and humanity might stand at the edge of its own survival. We know what must be done, and time is running out. Here on an island in the Caribbean Sea, Puerto Rico, a group of determined entrepreneurs, researchers, and investors has accepted this challenge and have embarked on a journey to replenish energy. In the words of the National Renewable Energy Lab of the U.S. Department of Energy, put quite simply, microalgae are remarkable biological factories capable of taking a waste form of carbon, CO2, and converting it into a high-density liquid form of energy algae oil. This oil also burns much like diesel fuel, but with 78% fewer toxic emissions. The vision of Replenish Energy is the integration of a myriad of processes, creating a facility that produces both food and fuel in an economic and environmentally sustainable system. By integrating the cultivation of microalgae and the certified organic aquaculture production of shrimp and tilapia, Replenish Energy has created a sustainable system that capitalizes on the efficient use of the sun through photosynthesis and the cycling of nutrients throughout the entire system. Key to the innovation process is a hybrid culture system that combines the controlled environment of a closed indoor tank system with this highly productive array of outdoor saltwater ponds. Microalgae are prolific producers of lipids or vegetable oils, with more than 100 times the production compared to land-based crops such as soybean. These oils have a host of uses, including fuel. Once harvested and extracted, this algal oil will be directly supplied as a biofuel for blending with petroleum or as a standalone fuel for the large nearby power plants of San Juan, as well as the private industry. Replenish Energy is a venture of Bio-Lipids of Puerto Rico, a private innovation company. The effort has built alliances with community and environmental groups, and with the scientific support and technical advice of the University of Georgia.
Algae have incredible potential. They're nature's power refineries, converting sunlight into stored energy that we can use. All we have to do is get to it. This is something scientists have known for decades, but until recently, the combination of technology, economics, and demand have never made algal fuels a reality. Replenish Energy, one of our partners, has a plan growing algae sustainably and creating fuels for power generation down in Puerto Rico.
PREPA is the single largest public utility in the United States. It provides all of the energy needs for Puerto Rico's 1.5 million customers, consuming 31 million barrels of imported oil per year, a 1.7 billion market opportunity. PREPA is 99% dependent upon fossil fuels, of which 70% is petroleum. Replenish Energy has located its pilot plant operations on a 320-acre site in Dorado, Puerto Rico, overlooking the Atlantic Ocean. The site, previously used for shrimp farming, is ideal for taking advantage of the ocean seawater, filtered through shallow wells, more than 12 hours of daily sunlight, and a mean temperature of 80 degrees Fahrenheit. The project will create near optimum growing conditions for microalgae. Adjacent to the microalgae ponds are parallel ponds of fish and shrimp that provide a symbiotic production advantage. The tilapia fish supply organic nutrients to the microalgae. The microalgae return the favor with protein, carbohydrates, and essential amino acids to the food diet of the fish. The shrimp are there for the cleanup. One needs to provide the microalgae with carbon dioxide. The project offers mitigation to industries that produce CO2 in their fermentation, such as Bacardi, and the smokestacks, such as the Power Authority. So while it is true that some CO2 is released when algae oil is burned as fuel, microalgae are the world's best carbon sink. The production of algae oil consumes even more CO2 than is released when burned, making it a truly carbon-negative fuel. Microalgae systems do not compete with land-formed farm crops, and the water resources can be salt or brackish water unusable for traditional agriculture. Microalgae biofuels offer an immediate solution that does not require changes in the infrastructure of today's power plants. Algae-based fuels can be used in existing facilities with no modifications, resulting in a rapid and low-cost transition to a renewable and sustainable energy option. This production model will produce a biofuel at lower than current petroleum prices. This algae biofuel process can be replicated throughout the world. The best part is that Replenish Energy is a reality today, and with the help of government and private funding, within just a few months, it will be leading the way as one of the 21st century sustainable and replenished energy sources.